So in this video, we're going to go ahead and learn about how we can solve a system of equations graphically or algebraically. We learned this method when we were talking about systems of equations that were in slope-intercept form. So you're going to recognize that all of these equations are in this y equals mx plus b form, where m is our slope and b is our y-intercept. So because they're in slope-intercept form, we can graph them. So looking at problem A, and looking at our first equation, we know that this is where you're going to start, your y-intercept, and then this is how you are going to move, right, which is your slope. So we're going to go ahead and put a point at -7. And my slope, when you move, you're going to move with a change of y over the change in x. So this 2 really is a slope of 2 over 1, which means I go up 2 over 1. Up 2 over 1. I can do this as many times as my heart desires. I can also go backwards, down 2, but to the left 1. And you're going to notice that we can draw a line through all of these points. So that's going to go ahead and be graph 1, the top graph. Now we can go ahead and graph the bottom equation here, where you have a starting value. Your y-intercept is going to be at -2. And your slope is going to be 3/4, which means you're going to go up 3 over 4. Up 3 over 4. And you're going to see that, hey, that pink point landed right on top of the blue point that I graphed earlier. And so we know that the solution is where they come together and intersect. So the x-coordinate is 4 and the y-coordinate is 1. Now, in this example, we had 2 positive slopes. So we went up each time and then we ran to the right. However, let's look at part B. You're going to notice a positive slope, a +5, and a negative slope, -2. So let's go ahead and look at how that graph shapes up. So the number chilling by itself, the number all by itself here is going to be where we start. So I'm going to go ahead and put a point at -3. And then my slope being 5, remember a slope's going to have a change in y over the change in x. So really this is a 5 over 1, +5 over 1. That's why we go up, because it's a +5. 1, 2, 3, 4, 5 over 1. Now remember, you can do this as many times as your heart desires. I like to do it a couple times because it makes my line more precise. Let me go to, there we go. And then I can go ahead and graph the next equation. I start at 4. That's my starting point. Now, my slope is -2. That's -2 over 1. So because that's a negative slope, I'm going to go down 2 over 1. And again, just like we saw last time, that pink point's going to meet up with that blue point that I graphed earlier. So where they intersect is your solution, 1, 2. The x-coordinate is 1, the y-coordinate is 2. So we can graph both of these, or we can find their solutions by graphing, but we also learned an algebraic technique. So the algebraic technique is, because they're both equal to y, what we can do is we can set them both equal to each other because they're equal to the same thing. So 5x minus 3 is equal to a -2x plus 4. I like to draw a line down the center of my equal sign, and then your next step is going to be combining like terms. So the numbers that are don't have the x are like terms, and the numbers, so 5 and -2x, are like terms because they both have an x. So I can either group my variables together or I can group my numbers together. There isn't a wrong way to do it, like in terms of a first step. It's just whatever your heart desires. I think that my heart desires to go ahead and combine the numbers first, so I'm going to go ahead and add 3. Now, the reason I'm adding 3 is because I'm subtracting 3 here. So the opposite of subtracting 3 is going to be to add 3. And what I do to one side, I do to the other side. So what remains on the left-hand side is a 5x, and what remains on the right-hand side is going to be a -2x plus 7. So now that the numbers are combined, my only move now is to move the x terms together. Now, I could move this 5x over, but it would leave me with 0. And I would rather have a number on sort of both sides of my equal sign. So I'm going to go ahead and choose to move the -2x. The opposite of a -2x is going to be a +2x. So I'm going to go ahead and add 2x. So if I add 5x plus 2x, my total is 7x is equal to, and again, these are opposites of each other. So that's why we don't write them. The whole purpose of doing the opposite is so that they essentially disappear. So I don't need to write anything here, but I do have this 7 still here, right? So my 7's still there. And my final step is going to be to go ahead and move that 7 over to the other side. I'm going to go ahead and do that by dividing. Because right now that 7 and that x is being held together with multiplication. So the opposite of multiplication is to divide. Which means that x is equal to a positive 1. So I have the x coordinate, and it's no surprise in our graphing we did get positive 1 here. So we know that we are doing our algebra correctly because it matches with our graph. My final step is to find that y coordinate, and the way that we do that is we choose what I call the easy equation. Really, easy is relative, so some students prefer this top equation because it doesn't have this negative 2x in front of it. It doesn't matter. You can choose either equation and it will work. I'll show you here in the video. So if I go ahead and I take my 5x minus 3, what you're going to do is instead of writing x, you're going to go ahead and substitute that 1 in. The one that we got here. So whatever number is here, you go and you substitute it in for the variable that you're given. And then 5 times 1 is going to be 5. 5 minus 3 is going to be equal to 2. Again, we got 2 when we graphed, so it totally makes sense. I did make a comment, though, that it doesn't matter which equation that you choose. You'll always get the right answer. As long as you do your math or you simplify correctly, it doesn't matter. So I'm going to show you here y equals negative 2x plus 4. If your brain thought not of this way, but you wanted to use this one as your easy equation, y equals negative 2. Again, you're plugging in 1 because that's the x value that I found here. Negative 2 times 1 plus 4 is going to be positive 2. So you can see I get the exact same answer. I get a positive 2 as my y coordinate. Should match with your graph. So the only tricky part here is when we are given a fraction, solving it algebraically, but I'm going to show you how you can eliminate that fraction. So just like we did before, we're going to go ahead and let me get rid of all this. We're going to go ahead and set both equations equal to each other because they're both equal to y. They're equal to the same thing, so they're equal to each other. So 2x minus 7 is equal to 3/4 x minus 2. Don't be intimidated by that fraction. In fact, the way that we get rid of fractions is we can multiply by whatever the denominator is in my fraction. So in this case, it's 4. So I'm going to multiply everything in this equation by 4. So 4 times 2x is 8x. 4 times negative 7 is negative 28 is equal to 4 times 3/4. That means that this 4 and this 4 are going to wipe each other out, leaving you with just a 3x. And you have 4 times negative 2, which is equal to a negative 8. So just like we did before, I like to go ahead and divide down the equal sign. And I'm going to go ahead and combine my numbers and then combine my variables. So I'm going to go ahead and choose to move this negative 28. The opposite of a negative 28 is a positive 28. So what I do to one side, I do to the other side. Now notice when I went to go write this, I put the 28 right underneath my number. There's no point in me putting the number below the variable here because they're not like terms. So I like to kind of keep my work organized. That's why I draw my little arrows to remind me, okay, which direction am I going? And I always place my number under the number that I'm going to either add it to or subtract it from or whatever sort of operation I'm using. So these are gone, right? That's going to become 0, leaving me with 8x is equal to 3x. A negative 28 plus 20, excuse me, a negative 8 plus 28 is positive 20. I'm now going to go ahead and combine my variables. So I can either move my 8x or my 3x. Because I don't want there to be 0 on the left-hand side, I'm going to choose to move my 3x. That's a positive 3x, so the opposite of a positive 3x is going to be a negative 3x. So I'm moving that in that direction. Again, that's gone. So what you're left with Let's see. 8x minus 3x is going to be 5x is equal to 20. Again, this is being held together by multiplication. I'm going to go ahead and divide both sides to get x by itself, and the final answer was x is equal to 4. Totally makes sense because when we graphed it, we did get an x coordinate of 4. So again, the algebra method or the graphic method, it doesn't matter which one you use, you're going to get the same exact answer. To find the y coordinate, you're going to go back and you're going to plug that 4 into your easy equation. I'm going to go ahead and choose the top equation because it doesn't have the fraction. That's what I think is easy. So y equals 2x minus 7. I don't know what y is, but I do know that x is 4, so I substitute that in. 2 times 4 is 8. 8 minus 7 is equal to 1, which makes sense because look, we got 1 as my y coordinate. So choose a method that you prefer. I do recommend that you do practice both methods because in this target, you do have to solve for the algebra method only. So keep that in mind.